Hello everyone, my name is Haoming Zhu. It's my honor to demonstrate the article Review on China's National Carbon Market and Analysis for Commercial Development Potential of Carbon Capture, Utilization and Storage in China. The first section is the introduction on CCUS. Well, according to the figures below, we may easily conclude two things. First is that energy-related carbon dioxide emission is the major reason causing the increase of global atmospheric carbon dioxide concentration. Another is that developing renewable energy is the fundamental way to reduce global carbon dioxide emission. However, it is impossible to thoroughly get rid of fossil fuels for humans. So that's why we need CCUS. CCUS consists of three processes: carbon dioxide capture, transport, and disposal. Currently, we have four technology paths: pre-combustion capture, post-combustion capture, oxygen-enriched combustion, and direct air capture. Mostly, we use the first three paths, but development of air direct capture CCUS offers more possibilities. But no wonder in which way we need to separate carbon dioxide from mixtures. Aqueous solution of organic amine absorption technology as a mature commercial technology has been used for the purification of natural gas and synthetic hydrogen since the 1930s, and has since been extended to carbon dioxide capture in post-combustion flue gas. Here are two application examples. The first one is the power plant in Malaysia, and the second one is a gas plant in North Dakota. However, as a mature commercial technology, aqueous solution of organic amine absorption technology also has some serious problems. For example, high energy consumption, the equipment corrosion, volatilization loss of organic amine is serious, and the secondary air pollution. According to this, a variety of potential alternative technologies have been extensively investigated, but are currently in the laboratory or small-scale demonstration stage. Above all, the direct carbon dioxide capture by air is still an important development direction in the future. Then, let's talk about the transportation. We've got four ways to transport the carbon dioxide: trucks, railways, pipelines, and ships. They all have different advantages and drawbacks. So, we should choose a proper way to transport carbon dioxide according to the situation. When we need to transport small amount of carbon dioxide a short distance, the trucks and railways are good choices. When the transport distance is within about 1,000 kilometers and a large amount of carbon dioxide is to be transported, pipelines transport is the most economical. And it may be economically more attractive to use ships when the annual carbon dioxide transport is below a few million tons, or when the transport distance is more than 1,000 kilometers. We also have different ways to utilize the carbon dioxide, like enhanced oil recovery, gas recovery. produce chemical synthesis and carbon dioxide-assisted chemical synthesis, or just direct carbon dioxide mineralization. And here are two examples. The first one is in Canada and the second one is in China. Aside from utilization, storage is also an important way to dispose carbon dioxide. We also have two ways to choose. The first one is geological sequestration. In this way, the carbon dioxide is injected into underground rock formations at a depth of 800 to 1,000 meters. Another way is marine sequestration. However, the marine sequestration and its ecological impact are still in the research stage. The next section is global CCUS projects. The first CCUS project began in 1972, and currently there are 137 existing and planned CCUS projects around the world, and 9 of them located in China. Among these CCUS projects, carbon capture, transport, geological sequestration, and carbon capture, transport EOR projects are the main pathways. And the next section is CCUS costs. Unfortunately, the high cost is a major reason of affecting large-scale application of CCUS. But as technology develops, the CCUS cost will go down in the future. And after 2025, carbon prices may exceed CCUS costs. And based on the facts, we've made market prospects and investment of CCUS. In China, since the national dual carbon targets were proposed, CCUS has been included in a series of policy documents issued by the government. And according to various national policies, the national attitude towards CCUS is still at the stage of carrying out key research and building demonstration trials. In 2021, the average carbon price was about 40 yuan per ton, but the carbon price will rise in the future, and the cost of CCUS will gradually decrease. In the long term, CCUS will be a necessary choice to achieve the last mile of carbon neutrality in China and even the world. Its relative volume is not large, but the absolute market size is very considerable. CCUS is predicted to make a carbon dioxide emission reduction contribution of 1 to 1.82 billion tons by 2060 in China, and will make a carbon dioxide emission reduction contribution of 8.2% to 14.9% to China's carbon dioxide emission peak, and it will create a market of over 100 billion yuan by 2035, and the scale will exceed 300 billion by 2050. And in the worldwide, many organizations are also optimistic about the future of CCUS. And here are some conclusions. First, from the Paris Agreement to China's 3060 goals, carbon emission reduction has become a national strategy. Second, affected by the epidemic and the international situation, the process of carbon emission reduction has been affected to some extent. Third, achieving the 3060 target will require accelerated implementation of carbon reduction technology in the future. Fourth, CCUS are likely to see rapid market commercialization as a last-mile solution to achieve carbon neutrality. Fifth, CCUS can be used to offset carbon emissions. And last, if carbon utilization technology can make a breakthrough, it will bring new industries, just like new energy vehicles. And that's all. Thanks for your attention.